Hello, good morning. Today let's use YouTube instead of Zoom. And then after that, you may tell me which one would you prefer to use, Zoom or YouTube. Which one do you think is better? Okay. So today, let's continue to talk about the probability distribution function. So this is the probability distribution of a random variable x. This is the distribution. This is the value of x, and this is the corresponding probability. And you have to find expected value of x and variance of x. So expected value of x, do you remember how to find expected value? Expected value of x. So E of x, right? So normally I put one more line to make it looks better. It looks prettier. So expected of value of x equal to each of the value of x times the corresponding probability. So first of all, we have -1 and then times 0.125. Okay? And then plus the second group, 2 times 0.25. And then 4 times 0.625. And then we're going to add them up. It will be equal to 2.875. This is the expected value of x, or the average of, or the mean of the x. Now what about variance of x? Do you remember how to find variance? Before we try to find the variance, there is a thing that we have to find first, which is expected value of x squared. Expected value of x squared. So value of x is -1. Then what about x squared? X squared means -1 squared, so it becomes 1. And then times the corresponding probability, 0.125. When x is 2, x squared will become 4. So we have 4 times 0.25. When x is 4, x squared becomes 16. So we have 16 times 0.625. And therefore, expected value of x squared is 11.125. And now we are ready to find the variance of x, because we have a formula. We know that variance of x equals to, first of all, expected value of x squared minus something square. What should it be inside? Just expected value of x. Okay, so this is the formula. Expected value of x squared, we have found already. It is 11.125. And then minus the mean square. Mean is 2.875 square. Therefore, the variance is 2.859375. This is the mean, and this is the expected value, and this is the variance of x. Yeah. Okay. Now, today we are going to do an experiment to look at the variation. Now, puppy. What about expected value of x plus 5? How to find the expected value of x plus 5? So, in order to find the expected value of x plus 5, we have to find the value of x plus 5. So first of all, when x is -1, -1 plus 5 will become 4. So this is the value of x plus 5. And this is the corresponding probability. Okay? When x is 2, x plus 5 is 2 plus 5, which is 7. When x is 4, x plus 5 will become 9. And then what about the corresponding probability? Just remain the same. So we have 0.125, 0.25, and 0.625. Okay. Now we've got the probability distribution, and now we are ready to find expected value of x plus 5. First of all, we need the value of x plus 5 times the corresponding probability. And then 7 times 0.25, and then 9 times 0.625. And then it becomes 7.875. After that, let's move to variance. Before we find the variance, there is a thing that we have to find first, which is expected value of x plus 5 square. We have to find the expected value of x plus 5 square. So first of all, we need x plus 5. When x plus 5 is 4, x plus 5 square is 16. So first of all, we have 16 times the corresponding probability. And then the square of 7 is 49. The square of 9 is 81. So it becomes 64.875. So we are now ready to find the variance. The variance of x plus 5. Remember the formula? The formula is, first of all, expected value of x plus 5 square minus something square, which is just the expected value of x plus 5. Therefore, we have 64.875 minus the square of the expected value of x plus 5. So after the subtraction, we have 2.859,375. Okay. And now, so let's do a comparison. So this is the expected value of x is 2.875, and this is expected value of x plus 5, which is 7.875. Do you see the difference? Yes, the difference is just 5. So when expected value of x is 2 point something, expected value of x plus 5 is just 2 point something plus 5, which is 7.875, just plus 5. What about the variance? For the variance of x, it is 2.85 something. And if the variance of x plus 5 is the same. So a variance doesn't change. Variance of x plus 5 and variance of x are the same. And then the expected value of x and expected value of x plus 5, the difference is 5. Okay, so let's continue to do one more experiment. This time, let's try to find, what about expected value of x minus 100 and also variance of x minus 100? So what would they be? Okay, let's do it. Now, to find expected value of x minus 100, first of all, we have to find x minus 100. and then times the corresponding probability. So when x is -1, -1 minus 100 is -101. When x is 2, 2 minus 100, -98, and 4 minus 100, -96. And the probability are the same. So we have this. Okay, we are ready now. Let's find the expected value. Expected value of x minus 100 is the value of x minus 100 times the corresponding probability, -101 times 0.125 plus -98 times 0.25 plus -96 times 0.625. So we have -97.125. So this is the expected value. And now to find the variance, first of all we have to find the expected value of x minus 100 square. To find the expected value of this x minus 100 square, first of all we need x minus 100 square first. So -101 square times the corresponding probability plus -98 square times 0.25 plus -96 square times 0.625. Then you will get, oh, very big, 9436.125. And now we are able to tell what is the variance. The variance of x minus 100 equals to this guy, expected value of x minus 100 square minus something square, which is the expected value of x minus 100. So that we have 9436.125 minus negative 97.125 square. And then it becomes 2.85935. Stop here. Okay. So again, let's try to compare. So you will see that first of all, the variance of x is 2.859375. The variance of x plus 5 is also the same, 2.859375. And then when it is variance of x minus 100, the variance remains the same. So that means that for variance of x, no matter you consider x plus something or x minus something, x minus 100, x plus 5, the variance remain the same. So when you put a constant, add a constant or minus a constant, the variance doesn't change. Then what about the expected value? The original expected value of x is 2.875. So when you have to consider expected value of x plus 5, you simply use the original expected value plus 5. 2.875 plus 5 becomes 7.875. Then what about expected value of x minus 100? So according to this rule, we just simply use the original expected value 2.875 minus 100, and it becomes negative 97.125. So do you see the relationship there? Let's try to draw a conclusion. The conclusion is that here. We have first of all the variance of x plus 5. We find that this value is 2 point something, which is equal to variance of x. And then we have also find that the variance of x minus 100 is also the same as variance of x. So therefore, we could conclude that when you consider variance of x, no matter you add or minus a constant, the result will still be variance of x. Okay, so that this is the first observation. And then the second observation is that we find that when we have expected value of x plus 5, the result is just equal to expected value of x plus 5. And likewise, expected value of x minus 100, this result is just equal to expected value of x minus 100. So that we could draw a conclusion when we have to consider expected value of x plus or minus a constant. The result will become just the expected value of x plus or minus the constant. Okay? So this is the conclusion. We have two rules about variance and expected value. And then, okay, now we know what to do when we have to add or minus a constant. Then what about times a constant? So x times a constant. Therefore, let's continue to investigate. So we are using the same example. This example, we have expected value of x and variance of x. And now let's consider expected value of 2x and variance of 2x. What if we times a constant to the random variable x? So to find the expected value, we need to know what is 2x. So when x is -1, 2x is -2, and then when x is 2, 2x is 4. When x is 4, 2x is 8. The corresponding probability remains the same. We have 0.125, 0.25, and 0.625. Okay, now we could find the expected value. Now, expected value of 2x is equal to each of the value of 2x times the corresponding probability. So that, first of all, we have 5.75. And then, in order to find variance, we need to find 2x squared. Expected value of 2x squared. So we need 2x squared. -2 squared becomes +4. 4 times 0.125. 4 squared becomes 16 times 0.25. And x squared becomes 64 times 0.625. And the result will become 4.5. So let's move on to find the variance of 2x. We know that according to the formula, variance of 2x equals to expected value of 2x squared minus expected value of 2x squared. So that means 44.5 minus 5.75 squared. And then we will have 11.4375. Okay. Now let's compare with the expected value of x. Expected value of x is 2.875. And then expected value of 2x become 5.75. Do you see the change? What is the difference? 2.875 and 5.75. What is the difference? Yes, 8.75 is 2 times 2.875. So this value is equal to 2 times the expected value of x. 5.75 means 2 times 2.875, which is 2 of the variance of x. Expected value of 2x equal to 2 times expected value of x. Then what about the variance? Variance of x is 2.x something, and variance of 2x is 11.4375. Do you see the change? 11.437 is equal to 4 times 2.85935 is 4 times the value of variance of x, which is 4, which is 2 square of variance of x. Okay, variance of 2x is equal to 2 square times variance of x. And now let's do one more experiment. This time we consider expected value of 3x. So we have to find all the value of 3x. When x is -1, 3x is -3, and then we have 3 times 2 becomes 6, 3 times 4 becomes 12, the corresponding probability. So, expected value of 3x is equal to -3 times 0.125, and then 6 times 0.25, and then 12 times 0.625, so that we have 8.625. And then 3x squared, the expected value is -3 squared times 0.125 plus 6 squared times 0.25 plus 12 squared times 0.625, and then it becomes 100.125. So the variance of 3x is equal to expected value of 3x squared minus expected value of 3x together square, so that it becomes 100.125 minus 8.625 square, and the result is 25.734375. And now let's compare with the original, the expected value of x. Expected value of x is 2.875. Then what about expected value of 3x? What is the relationship? 8.625 is a triple of 2.875. So it is equal to 3 times 2.875, which is 3 times expected value of x. Expected value of 3x is just equal to 3 times expected value of x. And then what about the variance? Variance of x is 2.8 something, and variance of 3x is equal to 25.7 something. So any special relationship here? If you do its division, you will find that it is equal to 9 times 2.859375. Okay? They're equal. And 9 could be written as 3 squared. It is equal to 3 squared times the variance of x. Is it interesting? So let's go back to here. When it is 2x, variance of 2x equals to 2 squared times variance of x. When it is variance of 3x, it becomes 3 squared times variance of x. Alright, so we can draw a conclusion now. The conclusion is, first of all, we find that expected value of 2x is just equal to 2 times expected value of x. And then expected value of 3x is just equal to 3 times expected value of x. So that we could draw a conclusion. When we have to consider expected value of a constant a times the random variable x, the constant could be a positive or negative number. It will just become a, the constant, times expected value of x. We can simply put the constant out, just like that. And then what about the variance? We find that variance of 2x is equal to 2 squared times variance of x. And then in the second experiment, we find the expected variance of 3x. Remember what is the result? It equals to 3 squared times the variance of x. Therefore, for variance of a constant a of the random variable x could be simplified as a square and then variance of x. Okay? So we have these two results. And now, together with the first part, let's draw an overall conclusion. The overall conclusion is that, first of all, we consider to add or minus a constant. Expected value of random variable x plus or minus a constant. And variance of random variable x plus or minus a constant. And then in the second part, we try to consider expected value of a constant times the random variable x, and also the variance of a constant times a random variable x. Do you remember the result? When it is expected value of x plus or minus b will become just expected value of x plus or minus b. And then the variance. For variance, no matter you add or minus a constant, the variance will become the same, variance of x. And then what about a constant times random variable x? For expected value, we simply move the a out, a expected value of x. And then for the variance, we move the constant out, but don't forget that to put a square, variance of x. Okay, so these are the rules. And then we could also combine these two rules to form a new rule. What about this case? What about expected value of a constant times a random variable and then plus or minus one more constant? What about this? Are you able to simplify this situation? First of all, we could move the a out, expected value of x, and then the result plus or minus b. For expected value, it could be simplified like this according to these two rules. And then what about the variance? Ax plus or minus b. First of all, the a will become a squared, variance of x. Do we need to add or minus b? No need, because add or minus a constant doesn't change the variance. The variance still be the same. So that we just need to move the a out and then put the square. Okay, so now today we have 6 rules about expected value and variance. We could use this rule to help us to do math to avoid using this table. If you know what is the expected value of and variance of x, you can skip these steps. So let me show you an example. This one. Given that expected value of x is 6.4 and variance of x is 10.44, you have to find two things. First of all, expected value of 6x plus 1. Expected value of 6x plus 1. Now, according to the rules, we know that it could be simplified as we could move the constant out, expected value of x, and then plus 1 could be simplified like this. So that because we are already given what is the expected value of x, which is 6.4. So that $39.4. Okay. So that by using this method, we do not need to draw a table and start from the scratch. Now, what about variance of 6x plus 1? Are you able to simplify this? So first of all, what to do with the constant 6? Is it just 6 and the variance of x? Do I miss anything? Don't forget to put a square. Do I need to plus 1? No need, because plus or minus a constant doesn't change the variance. So we do not need to plus 1, just 6 squared times the variance of x, which is 36. Variance of x is given 10.44. So we have 36 times 10.44, which is 375.84. Okay, so this is how we use the rules to help us to simplify regarding the expected value and variance. What do you think? Okay, please tell me whether you prefer the Zoom or using YouTube video. And tonight's homework is gonna be homework D. Homework D, how many exercises? There are 13 questions. Okay, please try your best. Bye-bye.